Imagine charging your EV in less time than it takes to grab a coffee and still driving 400 kilometers. Sounds like a fantasy. Well, BYD says it's already here. But are we looking at a true battery revolution or just a clever marketing? Today we cut through the hype, run the numbers, and see if BYD's Blade battery is as sharp as they say. Hello everyone, I'm Shayan, an engineer specialized in electric vehicle development. Back in 2020, BYD didn't just launch a new battery, they rewrote the rulebook. The Blade battery isn't your typical lithium-ion pack. It uses LFP chemistry, lithium iron phosphate. And each cell is shaped like, well, a blade. This isn't just for looks. The long fin design lets BYD pack cells directly into the battery case without bulky modules. In nail penetration tests, the EV industry's worst nightmare, the blade barely flinched. No fire, no smoke. Surface temps stayed between 30 and 60 degrees Celsius. That's like stabbing your battery with a steel spike and it just shrugs. Here's where it gets juicy. Tesla's 4680 NMC battery has around 241 watt-hour per kilogram and 643 watt-hour per liter. BYD's Blade about 160 watt-hour per kilogram and 355 watt-hour per liter. Translation: Tesla fits more energy in the same space and weight. But BYD's LFP chemistry is cheaper, safer, and lasts longer. We are talking 2,500 to 9,000 cycles before serious degradation. That could mean 15 to 20 years of daily use. In 2025, BYD dropped a bombshell. Their new Super E platform can deliver 1 megawatt of charging power. That's 1,000 kilowatts, enough to add 400 kilometers of range in just 5 minutes. Think about it, plug in, check your phone, unplug, drive away. But how? Blade sells redesigns for 10C charging, 1,000 volts and crazy high current. All kept cool with liquid-cooled cables. But here's the catch, ultra-fast charging isn't free. More stress means more heat and faster wear if you overdo it. On paper, the BYD Atto 3 promises 480 kilometers. In Australian testing, it hit 369 kilometers. A 23% drop, that's not bad. Almost all EVs lose range in real driving. But it's a reminder that lab numbers aren't gospel. Degradation-wise, early reports show about 8% capacity loss after 30 months. That's excellent for LFP, especially compared to some nickel-rich chemistries that can lose more than that in 2 years. Blade 2.0 is on the way. Expect even better cooling, up to 6C charging officially, but with 10C demonstrated in testing. BYD is also working on cell-to-body integration, where the battery becomes part of the car's structure. Lighter, stronger, more efficient. And let's not forget, BYD is dipping into solid-state battery research with a 60 amp-hour prototype already in the works. Here's why BYD can move so fast. They make almost everything themselves. Motors, chips, battery packs, 70% of their components are in-house. In 2024, they made 154 gigawatt-hour of batteries, second only to CATL. And in early 2025, they outsold Tesla in EVs by a lot. Let's do a quick calculation. At a 10C charging rate, a 100 kilowatt-hour Blade pack goes from 20 to 80% in about 6 minutes. That's adding 60 kilowatt-hour in the time it takes to microwave a popcorn. Cost-wise, LFP is still around 6% cheaper per kilowatt-hour than nickel-based chemistries. And because it lasts longer, the cost per kilometer driven is even lower. If you want the absolute longest range in the world, Blade might not be for you. But if you want safety, reliability, and stress-free charging, it's a strong contender. And with Megawatt charging rolling out, range anxiety could become a thing of past. BYD isn't just building cars, they're building trust in EV batteries. From the unbeatable safety record to the audacious push for 5-minute charging, the Blade battery proves you don't always need to chase the highest energy density to win. If you want to go deeper, I've put together a free PDF called BYD Blade Battery Explained, with charging rate calculations and safety test results. Perfect for EV enthusiasts, engineers, or anyone who's interested in EVs. Click the link in the description and you can download the file. If you found this breakdown useful, hit the like, subscribe, and share this with a fellow EV geek. See you in the next video. Thank you.